Welcome to this video where we'll go over some examples of chi-square calculations and setting up the testing hypothesis. So you have this example on Blackboard, and basically what you have here is you have two drugs, A and B. 80 people receive drug A and 80 people receive drug B. There's no reason why they should be equal sample size, but it just happened that they are. And the outcome of interest, so our dependent variable is whether the blood pressure is controlled or not. So you have controlled, not controlled. And in drug A, 65 out of the 80 have a blood pressure control. In drug B, you have 50 out of the 80 that have blood pressure control. And I've calculated the totals, yani the marginals, which by now you should know that we need them to calculate our tests. So 115, 45, and the total is 160. And what I did as well is I calculated the proportion of blood control in drug A, so 65 over 80, that's 81%, and 50 out of 80, that's 63%, okay? And basically the research question is there evidence to suggest that the proportion of blood pressure control between the two drugs is different or not different? Okay, so how do we set up Okay, remember as usual, you have your step number one is your null hypothesis. So you're going to write your null hypothesis. You're going to say, okay, since it's a proportion, you're going to write proportion is equal to proportion. And we just have to know proportion of what? Well, it's a proportion of a blood pressure control. Okay. For drug A is equal to the proportion of a blood controlled in drug B. And therefore, the alternative hypothesis is simple. These two are not equal. So that's step number one. Step number two, we're going to assume the null is true. So we assume the null is true. This is an assumption that we make every time. And we're going to set alpha, which we're going to set it equal to 5%. Okay. All right. So far, everything is fine. Next, we need to calculate the test. So you ask yourself your three questions. How many groups do you have? We have two groups, drug A and drug B. Remember, your grouping variable is your independent variable. Your outcome of interest is what? Well, it's if blood pressure is controlled or not, so that's categorical. And the third question is, are the group's member paired? Well, are they independent? Well, there's nothing that says that they are paired. So it's going to be the independent. So we're going to use the Pearson chi-square. Okay. So to be able to use the Pearson chi-square, if you remember the formula says that the Pearson chi-square is equal to observed minus expected. You square that difference and you divide by expected, and then you add them up because you're going to do that for every cell. How many cells do we have? All right, so we have 1, 2, 3, 4 cells. I'm just going to go ahead and calculate the degrees of freedom just so that we get it out of the way. So degrees of freedom is number of rows. So we have 2 rows. Remember, when you're counting the rows, you don't count the total row. So you have 2 rows minus 1. You have 2 columns minus 1. So that gets you 1 times 1. So our degrees of freedom is 1. Okay. So again, degrees of freedom is going to be, how many columns do we have? So number of columns minus 1. And you multiply that by the number of rows minus 1. Okay, so we just said that we had 2 columns minus 1, and we had 2 rows minus 1. So that is 1 times 1, that's equal to 1. Okay, so let's now apply the formula of the Pearson chi-square. The formula says observed and expected type. If you go back to your Excel sheet, you already have your observed. 65, 50, 15, 30, these are the observed values. But now I need to get the expected value per cell. So what is the expected value of the 65? We mentioned previously to get the expected value, you take the total of that row, يعني 115, you multiply it by the total of that column, يعني 80, and you divide by 160, okay? So you're going to take 115 times 80 divided by, so for cell A, the first one, the expected is 115 times 80 divided by 160, okay? So that is going to be equal to, I think it's 67.5, okay? So this is the expected for cell A, the expected, yes, and the observed was 65, okay? All right, so for that, the observed for cell A can 65. Okay, so and the observed and the expected. If I want to start doing my chi-square, I can say 65 minus 67.5, square that difference, يعني هيطلع 2.5. You're going to square 2.5 and you're going to divide by 65 ولا 67.5. Well, it's the expected, so it's 67.5 plus. So that was for cell A. Now you're going to do it for cell B, cell C, and cell D. Okay. So cell B, it's for this one. So the row total is 115 come in. The column total is 80 come in. It happens it's the same one because عندي 80 ب 80 هون. And divided by 160. So actually the expected كمان هيكون هو ذاته هيكون 67.5 for cell B. Okay. So for cell B, if I need to correct شوي, for cell B, it just happens that it's going to be نفس الشيء 115 ب 80 divided by 160. So كمان I'm gonna get 67.5. But the observed for cell B is not 65. It's actually 50. Okay. So here is بدي كمل بدي أحط 50 minus 67.5 square. Okay, and you divide by 67.5 plus, you're going to do cell C, يعني 45 times 80 divided by 160, so that's going to get you 22.5, and you're going to actually get also 22.5 for this cell as well. هيك بيكون صار عندي the 4 expected for these cells, and I think I already did that calculation. Okay, so هون هن expected 57.5 ب 57.5, 22.5, 22.5. This happens when you have equal numbers in every group. Okay, and you shouldn't be surprised because remember the expected is according to the null, and the null says equal proportion, so these should be equally distributed. Type then what do I need to do? مثل ما كنا عم نقول, you take the observed minus expected, you square, you divide, you get, so for the first cell I got 0.978. For the second cell, actually it's the same calculation, you're going to get also 0.978. For the D, that's 15 minus 22.5, you square, you divide it by 22.5, you get 2.5, and for the last one, 2.5, you add these 4 values together, you get 6.95. This is the chi-square that we calculated, okay, 66.95. So, if you want to figure out the degrees of freedom, sorry, the p-value, I'm just going to go to my chi-square table. Degrees of freedom is 1. I calculated 6.95 if I'm not mistaken, right? 6.95, right? Okay. So you come to your table and you find that the 6.95 is somewhere here, degrees of freedom 1, Akid, don't forget about the degrees of freedom. It's between these two values. So your p-value is between 0.01 and 0.001. So we go back to our testing hypothesis steps. let's finish our testing hypothesis. So our p-value is less than 0.01, but it's greater than 0.001. Okay, so step number 5, our p-value is less than alpha. Step number 6, we're going to reject the null hypothesis. And the last step is our research conclusion. So research conclusion, let's go back to the Excel and let's notice that I had 81% in drug A and 63% in drug B. So I say that we have enough evidence to suggest that the differences in proportions between the blood pressure control between drug A and B, this difference is statistically significant, meaning that it appears drug A, people take a high proportion of people taking drug A have blood pressure control than those taking drug B. So let me write it up here. I'm going to try to write it. So I will write it. I'll write it here. Okay. So we have evidence that a higher proportion of patients taking drug A have a controlled blood pressure as compared to patients taking drug B. Okay, so you say that the difference is statistically significant. Um, if um, if your conclusion was correct, so what have you achieved? So that's where you're going to come and think about هذا اللي حكينا عم نحكي عنه دائما. So this is if the null is true, if the null is false in its reality, this is failing to reject, and this is rejecting, and we already have set it up. So you know that this is 1 minus alpha, this is alpha any type 1 error, this is beta, and this is 1 minus beta. We rejected, we're here, and I'm saying that this decision is correct. So we have achieved 1 minus beta, which is power. معناتها the reality of the null hypothesis is false. And basically that's it. Okay. One last thing again about p-value, because it's very important that you understand what's the p-value. What does it mean? Well, this is the probability, okay, of observing this much of a difference between these two proportions, or even more extreme. So so if in reality whole two drugs were exactly same efficacy in terms of blood control, إذا ما في فرق between these two drugs, the probability that I observe this much of a difference between 81% and 63%, the probability of observing that much of a difference, or even a greater difference, more extreme difference, is between 1 per 1,000 and 1 per 100. That's the definition of a p-value. Last thing I want to remind you of effect size. What is our effect size here? So remember, our simplest definition of effect size is the observed difference. So since I'm observing 81% and 63%, the difference is about 18%. So my effect size is actually 18%. Okay? Azim. The last thing I did in this exercise is that I've calculated the chi-square using the shortcut formula. So let me remind you of the shortcut formula. The shortcut formula works if you have only 2 by 2 table, and it has the following formula. So it's AD, and you work with the observed value, AD minus BC. You square that difference, you multiply by the total sample, and then you divide by the total of row 1 times the total of row 2 times the total of column 1 times the total of column 2. Okay, so if we go back to our data right here, it's you take 65 times 30 minus 50 times 15. You don't worry primary is a value, the result is negative because you're going to square that value. So whatever the value you found, you square it, you multiply it by 160, and then you're going to divide by 80 times 80 times 115 times 45, and you're going to get the exact same thing. Then one thing that I forgot to mention is about the requirement of the chi-square. The requirement of the chi-square has you looking at the degrees of freedom. And since the degrees of freedom are, sorry, I said degrees of freedom, I mean the expected values. So I have 4 cells, and none of these 4 cells have an expected value less than 5. So the percentage of cells with expected less than 5 is 0%, and that is totally fine because as long as it's less than 20%, I'm fine. Okay, so that covers this exercise. There is this other exercise that is also on the blackboard, and it reads, researcher interested in the impact of nicotine overuse on memory loss. She got 35 rats. First, she had them memorize a maze, and then exposed half of them to nicotine overdose. Then had all 36 rats back into the maze. Of those exposed to nicotine, 10 were able to remember the maze, and of those not exposed, 15 remembered the maze. Okay, so think about it this way. 36 rats divided into 18 and 18. 18 were exposed to nicotine and 18 not exposed. And then we wanted to see if they will remember the maze well or not. So how many groups did we have? Well, 2 groups, those exposed to nicotine and those not exposed to nicotine. Should outcome if they will remember or not remember so wholly they will remember and whole will not remember. Okay, so categorical outcome. Are these the same rats? No. So we're going to use the Pearson chi-square. Okay. So the first thing you're asked to do is what you think the research question is going to be. Well, obviously, whenever you write a research question, you have to think about what is your independent variable and your dependent variable. So our independent variable is exposed well a lot to nicotine. Our dependent variable is whether they will remember or not. So the question becomes, is there evidence that exposure to nicotine will impact the proportion of rats remembering the maze? That's one way. Or you can say that هل يا ترى nicotine influences memory among rats? So whatever you decide on how you're going to write it up, you need to write your research question in such a way that you're going to mention the nicotine exposure, okay, because this is your grouping variable, this is your exposure variable, your independent variable, and you're going to also mention memory, whether they remember or not, because this is your outcome variable, okay? So you have the results right there. So, but you also are provided with the value of the chi-square and the degrees of freedom of the chi-square, and you're also provided with a p-value. So you are provided with everything. So the question is, what would be the conclusion here? Now, notice that the p-value is between 5% and 10%, and therefore you're going to fail to reject. So شو معناتها failing to reject؟ يعني I do not have evidence to suggest that there is a difference. I cannot say that this 55% of rats remembering the maze exposed to nicotine is different than the percentage of rats remembering the maze not exposed to nicotine. Okay. So what do you say about the difference? But notice here you have 55.5 and here you have 83.5. So the percentages are different. Well, you say that this difference is due to chance only. Remember, لما ما بيكون في statistical significance, يعني when we fail to reject, we say that the difference observed was due to chance only. All right. Okay. So you can actually set it up yourself as a button. You can actually do the calculation, make sure that you're going to get the same chi-square, same degrees of freedom, and same p-value. All right. Okay, I hope you enjoyed these examples. I'm going to add one more example about the McNamara.